All right, we just got done with problem 4. Here comes number 5. Use the parallelogram. Now, remember, none of this stuff's going to be here. I'm going to cut all this stuff off. It's not going to be a matching exercise. All right, it's going to be you fill in the blank. It'll say something like, how long is segment, I don't know, EH, and you'll have to look over here and say, okay, EH is across from 6. So EH is 6 long. All right. So when I print these things out, they're coming from, the computer. So it's this one was a matching exercise. So you'd say, okay, well, EH is equal to 6 right over here, right? And then it wants us to figure out what EI is. So how long is EI? Well, the diagonals bisect each other. So EI is 4 long. Okay. So EI, oh my goodness, that's a terrible E. EI is 4 long. And then we know that because the diagonals bisect each other, IH is, or they put it as HI, 5 long. All right, that's how question number 5 is going to be. It's going to be, pretty basic stuff about a parallelogram. Fill in the blanks using the available answer choices. Use the figure to complete the statement. All right, so it says DE and CF blank, the same slope, and are congruent. Again, I'm going to have to change this problem because it's not just to fill in the blank. So let's see how I could modify it a little bit right now. And I might ask you to find the slopes. So what are the slopes of DE and CF? Okay, so I would ask you to show me how to find the slopes of DE and CF. So let's look right here. Here's DE. And how much are we going over? You could just do it like this. 1, 2, 3, 4, 5, 6. Okay, so my run is 6. Run goes in the denominator, right? Our slope is rise over run. I just did the run part. Now I'm going to go up by 1 right here. So it's going up by 1. So that's 1, 6. Let's measure the slope of CF. Well, that's probably going to be the same thing, right? 1, 2, 3, 4, 5, 6, up 1. All right, so we got the same thing. Rise over run. All right, they have the same slopes, so they're congruent to each other, right? Oh, wait. Well, they are congruent, but not just because they have the same slope. I mean, the run and the rise are exactly the same, 6 and 1. So using the Pythagorean theorem, we could say that DE is equal to the square root of 6 squared plus 1 squared. So I'd ask you, hey, what is the length of DE? And you get the square root of 37. And then we know that CF is the same thing. So CF is, let me fix something here. I don't want the little bars over the top. I want to say their measure, their length, right? So length with no bar means, this two letters means how far apart are the points, right? So I'm going to do the same thing, square root of 6 squared plus 1 squared, and you get square root of 37. So their lengths are the same, and their slopes are the same. So that means they are parallel, right? So parallel, this means they're congruent, and so we've got a parallelogram, all right? Let's go down to number 7. We'll try to do 4 each time. Okay, 7's on the next page. It says parallelogram ABCD has those vertices. What are the coordinates of point C? Okay, so on the test, I'm going to have like a little XY axis out here to the side, right? So let's draw one here in our notes. And I'm going to ask you to plot the points. So we got 0, 0, we got 2, and we got 4. So let's say 4 is up there. There's 2. So 2, 4. Okay, let's label it 2, 4. And this is point B. And this was point A. All right. And then we've got C is at some random XY. Okay, so let's see here. I'm going from A to B, then to C, then down to D. And D is at 5, 0. So I come over here to 5, 5, 0. Well, this is kind of dumb because it's just going straight across from, this is where D is, right? D's at 5, 0. So that means, oh, wait a minute. See, this one's horizontal, so is this one, but B is over here at 2, 4, right? So like I'm going over 2 and I'm going up 4. Well, I got to do the same thing here. I got to go over 2 and I got to go up 4 so that this one's horizontal, right? Like these two sides need to be parallel and the same length. You could have done it that way. You could have said I'm going from 0 to 5. It's 5 long. So I got to go from, from here to here, it's got to be 5 long, right? And so I come over here and I put a dot right there and I call that C. And I didn't mean to do that. Let me see if I can neaten that up a little bit. C is equal to, let's see, if I went 5 over, I'd be at 7, 4, right? Because I'm going 2 plus the 5, that's my 7 right there, my X value, right? All right, woo! I don't know. I might make that one a little bit more difficult. I don't know that I like the horizontal aspect on this side down here, but it is challenging that C is kind of, see, like when they list them A, B, C, D, you got to go in that order. So A, B, C, D, right? You can't go like this. A, B, you can't go diagonally. It won't go A, B, C, D. No. They just go around the figure and letter it, okay? Quadrilateral PQRS is a rectangle. What is the measure of QSR? Okay, so let's look. QS, like that's the first thing our eyes have to do. We have to figure out where the heck QSR is. It's this angle right here. The S is the vertex. It's the middle letter right there. So S is the vertex. And so we need to put at S at the point where the two sides of the angle come together. All right, now what do we know about this rectangle? Well, it's a 90-degree angle up here in the corner, right? They're all 90-degree angles since it's a rectangle. And let's see, we've used up 50 degrees here. The diagonals are congruent to each other and they bisect each other because they're parallelograms. Rectangles are parallelograms, so the diagonals bisect each other. Anyways, that means these two pieces are equal because the diagonals are equal to each other. And then that would mean that I'd have, I'd have two angles here, like an X here and an X right here. And you might say, well, I don't care about those angles. I want this one over here. However, the sum of these have to add up to be 180, right? So if I go 50 plus 2x equals 180, and I subtract 50 from both sides, I get 2x equals 130. Then I divide both sides by 2, and I get x equals 65. Okay, this angle right here is 65. So is this one right up there. Oh, that means that 90 minus 65 would be 25, I think. This angle right here has to be 25 so that the two add up to be 90 degrees, right? They're complementary. All right. Hey, there's another 4 problems. You made it. Good work.